Okay, in this video, we are using the change of base formula, learning it and applying it. So what is the change of base formula? Says, if I have some log and I have a base of something, a, yeah? And here's the inside of the log. I'm taking the log base a of whatever it is. And I can rewrite that with whatever base I want, any base of my choosing. I just put the m on the top and the b in the bottom. So it's the log of the base that I want, right? The base that I choose, and then the m goes up top, the original base goes down below. So to me, it's the way I always remember it is like you just look at the position of the things as they are. So from this original log, if you look at where it's located, where the m is located, it's located higher than the a, right? So that's how I remember which one goes up top. The top one up top, bottom one bottom, and the base is of my choosing. Now, because the base is of my choosing, most of the time, it makes sense to choose one of the most common ones, right? Either natural log or the common log, which is base 10. Or maybe another popular choice would be another popular candidate for contention in the Olympics of the logs would be base 2, because 2 is also a nice base. Okay, but the positive thing about ln and the common log is these guys are in pretty much every scientific calculator. So if you wanted to just punch something into a calculator, scientific calculator, then you could just use a change of base formula and they can do it with ln or log. But nowadays, though, a lot of the calculators also have a function for you to choose the base, and so that's sometimes not necessary, but depends on the calculator. Okay, let's try 19 through 21. I should just mention briefly the typical things, right? But this is nothing new. These are all kind of the old things. Why come a, b, and m all have to be bigger than 0? Because, well, first of all, a and m got to be bigger than 0 because those are inside of the log function at some point, right? How come a and b cannot be 1? Well, both of those are in the base at some point. And if the base is 1, remember we have an issue because 1 to any power is just 1 itself. So you don't have a regular logarithmic function. You just have a constant 1 function instead. But we talked about that before. Okay, 19 to 20. Is that it? Just those 3 questions? Oh, yeah. Easy peasy. Oh, maybe we'll go home early today. Except I am home early. Last time we went a little overtime, yeah. So this will hopefully make for it. But I shouldn't say anything like that because it ends up taking longer than I think every time. Okay, 19. So it says use a change of base formula, change to a form you can input to a calculator, then give the decimal approximation to the nearest 4 decimal places. Okay, sure. So log base 3 of 20. Just simple straight application of the formula. I'm gonna choose the natural log as my base. What I mean by that is that I'm changing to the base e. So I'm gonna choose natural log up top, natural log up bottom. That's my choice to change to natural log. And which one goes on the top? The top number, the 20. Which one goes down? The bottom number, which is the 3. So there it is. That's it. Okay, now I gotta enter 2 in my calculator, yeah? So, oh, wrong one. This one. Okay, so what was I doing? Okay, I want a function, yeah? Okay, function, notice there's a ln built in. Also a log built in. I could choose either one, but I chose ln. So I'm going to do ln of, what was it again? 20 up top, 3 down bottom. Oops. Okay, ln of 20 up top. And that's divided by ln of 3 down bottom. Notice, guys, in this calculator, it does seem like it's the case where they don't have just a random log function built in. They only have the natural log and the common log. So, what's necessary? Okay, and then here I have approximation. So 2.7268, 2.7268, 2.7268, 2.7268, 2.7268, 2.7268. And that was an approximation because we rounded. So we'll use the squiggly equal sign. There's number 19. Let's do number 20, same spot. Log base square root of 2. What a weird choice for a log base. Okay. Let's choose the other log this time. Let's choose the common log. So I'm going to say that's equal to log of something up top over log of something down bottom. And which one goes up top? The one that's higher. So it's a log of root 15 on the top, log of root 2 down bottom. And I'm just going to plug that in. Log root 15 or log root 2. Just an idea to show you guys something. So let me do this first. Log. Oops. Log over log. Yeah. And this was square root of 15 up top and square root of 2 down below, right? So I got about 3.90689. Let me just double check I have the right numbers. 15 over 2, yeah. 15 and 2. Okay, what I want to show you guys though is check this out. So I'm gonna use a different one. Let me try natural log, same numbers. And in theory, this should be the same, right? Oops. Because that's the whole point, right? It says the change of base formula says should be able to choose any log I want. So if I choose natural log, I should come up with the same answer. So let's see, square root of 15 up top, square root of 2 down below, and voila, you do get the same number, 3.9068. Now, of course you do, because that's what the change of base formula is. 3.90689. Or to the nearest 4, 9069. So 9069. 9069. 3.9069. Okay, there you go. About 3.9069. That was number 19 and 20. So now we know how to use the change of base formula for that. Okay, number 21 says find an equation of the form y equals to c plus b log base ax, where a, b, c are integers whose graph contains the two given points, 2, 1, and 4, 5. Okay, you first see that question. It sounds complicated. And actually, this one is a little bit long. Sounds complicated, and it's kind of complicated a little bit. Okay, but let's look at the information we're given. We want an equation of this form. It's a log equation, right? Plus we got constant being added, something being multiplied, and some base. Now, it doesn't say find the equation. It says find an equation. And that tells me there's actually more than one possible answer here. But as we do this, I'm going to choose what to me makes sense to be the most natural choice. Now, it's only going to be one choice. But I'll choose a choice that is natural. Now, what does 2 and 1 tell me and this 4 and 5 tell me? Well, those tell me the x and y's, right? This is one choice for x, one choice for y, one choice for x, one choice for y. So I get two new equations. And what immediately comes to mind is like, when you have these system of linear equations, you have like a bunch of linear equations, and then you have to solve for multiple variables, and then that kind of thing, right? You're trying to look for some cancellation. You plug in the numbers you got, cancel an x's or y's, or cancel out some variables that you have. And that's what we're going to do here. First, I'm going to write two new equations. One for 2, 1, and one for 4, 5. Okay, so let's do the 2, 1 first. Here, y is 1, right? B log base A of x, and x is 2. Yeah, that's the first equation. Second equation, using 4, 5. Well, y is 5, so it's 5 is c plus b log base A of 4. Okay. So here we have a little choice to make for the base. And I'm looking at a log of 2 and a log of 4. And immediately what's coming to mind to make the most sense is to make A 2. Because if A is 2, that's going to match perfectly with this 2, right? A to what power is 2? It's just 1. A to what power is 4? It's just 2. A to the 2 to the second power is 4. 2 to the first power is 2. So let's make a choice here. Let's let A equal to 2. Okay. So I'm going to get simplified equations here. I'm going to write those in green. I'm going to take these two equations, yeah? And then I'm just going to apply this. I'm going to apply that new formula. So, yeah. So like this. 1 equal to c plus b, and then log base, this is going to become now log base 2 of 2. But this portion, log base 2 of 2, 2 to the what power is 2? This is just 1. So 1 is equal to c plus b times 1. Or, if multiplied by 1, I don't need to write that 1, right? That's the first equation. Okay, what about this guy? Let's do this guy. So I had 5 is equal to c plus b log 2 of 4. What's this log 2 of 4? 2 to the what power is equal to 4? And the answer is 2. So I got 5 is equal to c plus b times 2. Or 5 is equal to c plus 2b. Okay, and now I do, in fact, have a system of linear equations, right? I don't know if you guys remember this from whatever class you learned it in. I've got two equations with two variables. That's going to enable me to figure out what those two variables should be, c and b. So let's go ahead and use one of our techniques to solve that. And I think the most one technique that makes sense here is to just subtract one equation from the other one, because the c's are going to cancel if I do that, right? So I'm going to take this guy, subtract it from this guy. You could go either direction, but I'm going to go that way because that makes the most sense since this is the smaller number. But either way, it doesn't really make much difference. Okay, so I'm going to subtract this other formula. 5 minus 1 is 4. C minus C cancels. 2b minus b is a b. So already b is equal to 4. Okay, now let's circle that in black. Okay, so now I'm going to take that and just choose one of these, either one of those formulas I had highlighted in purple and stuck in the 4 for b and see what pops out. So let's use this one right here. 1 is equal to c plus b is now 4, right? So it's sticking 4. And that means subtract 4 plus sides. C is negative 3. Okay, so got my 3 letters. I selected A strategically. That led me to figuring out what C and B must be to make everything work with those two equations I had. And so now I'm ready to answer the initial question. We've been answering everything in red, so let's stick to red. Y equals negative 3 plus 4 log base 2 of x. This is my formula. And you can double check that it works by plugging in these values for x and y and seeing that it turns out to spit out a true equation. In fact, here, let me just do one of those. Let's do 2, 1. This is just an extra check. But, you know, this will help us to catch mistakes that we made along the way. Right, so I'm going to replace this x with 1. Oh, I'm sorry, no, 2. X is 2. And then replace this y with a 1. And if it's correct, it's gonna make the equation true. 1 is equal to negative 3 plus log base 2 of 2 is 1. 4 times, this is 4 times 1. 1 is equal to negative 3 plus 4, which is 1. Yes, checks out. Okay, that's it. All right, see you guys in the next one.